We have started our syllabus related to SYBSc physics, and we have started today. We are going to start our new chapter, that is chapter number 2, study of transistors. In this chapter, we have to study what are the transistors, what are the types of transistors, how the conduction takes place in the transistors, and what are the applications of transistors. First of all, we will understand what is semiconductor. These transistors are the components, electrical components, which are made up of semiconductors. We know that semiconductors are the materials whose conductivity, electrical conductivity, remains or present in between the conductivity of that of conductors and insulators. And there are two types of semiconductors: P-type semiconductors, P-type semiconductors, and N-type semiconductors. When we consider a pure element, and if we add a pentavalent impurity in it, it means that element which will have 5 electrons in its outermost orbit, then there will be excess of electrons, and this will give rise to N type of semiconductors, because these semiconducting materials consist of excess of electrons in them, and hence they are named as excess of electrons means negativity, hence they are named as N type of semiconducting materials. And when we add a trivalent impurity, when we add a trivalent impurity, or if we take a pure germanium or silicon crystal, and in that if we add a trivalent impurity, then what will happen? There will be a absence of electron. Therefore, there will be absence of electron is nothing but hole. And therefore, the majority charge carriers in case of these materials are the holes, and they are called as, holes means positivity. Therefore, they are called as P type of semiconductors. So, now in today's lecture, we are going to see a new circuit component, that is transistor, which is made up of a semiconducting material. And this um, element is very much important because it has covered, or it is having a wide potential in semiconducting or in electronics technology, because most of the computers, then laptops, then many things, they are made up of these transistors, or every circuit element, every circuit component, they are consisting of these transistors. Therefore, these are widely used in various electronic machineries or electronic gadgets. So let's see what are the transistors. So the transistor is a device which is having 3 terminals, and they are made up of semiconducting materials. It consists of 2 p-n junction diodes. We know what is p-n junction diode. Suppose we take a semiconducting material, and if we dope them with P type of material, or if we add a pentavalent impurity and N, means pentavalent impurity and trivalent impurity in them, then they will give rise to a P type and N type of semiconducting materials. And when we make a junction with the help of this P type and N type material, then they will form a diode. And our transistor, this is a circuit component which consists of 2 such semiconducting diodes, or p-n junction diodes, and hence they are called as bipolar junction transistors. Let's see their construction. Construction of bipolar transistors. So just now I have told you that transistors are the circuit components which consist of two p-n junction diodes. Therefore, this is n-type, this is p-type material, and this is n-type material. It means that it consists of two n-type materials, and in that a p-type material is sandwiched as shown in figure. Therefore, there are the formation of two junctions. Means here one junction is formed and here another junction is formed. Like that, there is formation of two junctions, and it will have three connections like this. This material is called as emitter. This portion of the transistor is called as emitter. This portion is called as base, which is situated at the center, and this is called as collector. It means that a transistor consists of three connections, that is three terminals: emitter, base and collector. Emitter, base and collector. And here in this transistor, in between two n-type materials, a p-type material is sandwiched. There is one more situation where the n-type material is sandwiched in between two p-type materials, and that transistor is called as Pnp transistor, and this transistor is called as NPN transistor. Now we will draw the circuit diagram of PNP transistor. Here I will make the collector portion of the transistor somewhat large in size. Here also it will be a emitter, it is base and it is collector. These are the three terminals. Here in this transistor there are two junctions. One junction is situated here and another junction is situated here. And here a n-type material is sandwiched in between two p-type materials, and this is called as PNP transistor. Just now I have told you how to form a n-type material. A pure germanium or silicon is taken, and in that if we add a pentavalent impurity, then there will be excess of electrons. It means that the majority charge carriers in n-type of material are electrons. And what about p-type of material? If we add a trivalent impurity in a pure germanium or silicon crystal, then what will happen? They will create holes. Therefore, the majority charge carriers in case of material, this material, p-type material, are the holes. Here, holes will be the majority charge carriers and electrons will be the minority charge carriers. Here also a p-type material, hence majority charge carriers will be holes. This is electron and these are holes. In case of n-type material, n-type semiconducting material, majority charge carriers are electrons, and in case of p-type semiconducting material, majority charge carriers are holes. Absence of electrons is nothing but holes. Therefore, conduction in case of n-type material takes place with the help of electrons, and conduction in case of p-type of material takes place with the help of holes. Then how to determine whether it is a emitter, whether it is a base, or whether it is a collector? Because these two terminals are having n type of material. Then in the construction of bipolar transistor, the situation is that the base is the portion of the transistor which is less in size. Therefore, one should draw it like this. Therefore, it should be less in size. Then, if we compare this section and this section of transistor, then this section, length of this section should be less than that of this section. Therefore, the length of collector section should be less than that of emitter section. So one can easily identify whether it is a base, whether it is a emitter, or whether it is a collector, because the length of base is situated at the center, then length of emitter is less than that of collector. Then one by one we will see what are the workings of emitter, base and collector. Here also one can make, here it is shown, one can make this portion as less and this portion somewhat wide. So one by one we will see what is the working of emitter, then what is the working of base, and what is the working of collector. Just now I have told that the emitter base, there is biasing of the transistor. It means that in order to get higher output than that of input, or higher power than that of input, there is use of biasing. One has to bias the transistor. There are various methods to bias the transistors, but in general there is forward biasing, the emitter base junction, and reverse biasing, the collector base junction is used. So this portion is called as emitter base junction, this portion, and this portion is nothing but the collector base junction. Therefore, such two junctions are present in the bipolar transistors. So just now I have told you that the emitter base junction is forward bias and collector base junction is reverse bias. Emitter base junction is forward bias and collector base junction is reverse bias. It means that suppose this is N, then negative terminal, then it should be connected to the negative terminal of the battery. This is called as forward bias, and reverse bias means this is the negative terminal, so it should be connected to the positive terminal of the battery. This will give us the reverse biasing of the transistor. So we will see what is the use of emitter. When we apply forward bias to the given transistor, then these electrons will start to move or start to pass through this base. And base is made up of, or base consists of, the minority charge carriers, and these are holes. Base consists of minority charge carriers, that is holes. That's why what will happen when current start to, that is electrons start to move from emitter to holes or the base, then what will happen? There will be the electron and hole recombination process. Recombination process takes place, and because of that there will be generation of valence electron. Therefore, there will be generation of valence electron, and this valence electron will start to migrate through this base, and it will give rise to base current. When current starts to flow through the emitter, then there will be observance of emitter current, i.e. Therefore, base current is formed, emitter current is formed. Now, the about 5% of the holes and electrons will get recombined in this section of base, and about 95% of the electrons will get transferred through this junction, that is through collector base junction, and hence these electrons will give rise to a collector current IC. So these are the functions of emitter, then base and collector. What is the function of emitter? When we forward bias the emitter base junction, then electrons will start to migrate through this portion, and they will cross the barrier and they will come to base. Here in base there are the presence of minority charge carriers, that is holes. These electrons coming from the emitter will combine with the holes, but their combination is having the percentage of 5% only, and the remaining 95% of the holes electrons will get transmitted through this collector base junction, that is this junction, and they will create the current that is called as collector current. This is the construction of bipolar transistor in case of NPN transistor. Then what about PNP transistor? The construction of PNP transistor is on the similar guidelines like that of NPN transistor. Here, instead of P-type material, we are using N-type material, and instead of N-type material, we are using P-type material. That is, in between two P-type materials, we are sandwiching the N-type material. Therefore, the emitter is the junction. Emitter is the portion of the transistors which will have majority charge carriers as holes. Here, majority charge carriers in case of emitter are holes, and this portion is called as base. The structure of this PNP transistor is same because the base will have a small size and its doping is also very less. Therefore, it will consist of minority charge carriers, and it is light. It is light and thin. Here also the base is light and thin. Now, the majority charge carriers are observed in emitter, and these are holes, and the base is made up of N type of material, and they are contributing to minority charge carriers in base, and these are electrons. So, when we apply a forward bias to emitter base junction, then what will happen? This emitter base junction, then these holes will try to migrate towards the base, and because of that there will again be the electron hole recombination process takes place inside the base region, and because of that there will be the creation of valence electron, and that valence electron again will give rise to a current which is called as leakage current or base current, and that is nothing but IB. Due to the migration of holes, there will be the generation of current in an emitter section of the transistor, and that is called as emitter current IE. Now, we have seen here that about 5% electron hole recombination takes place and 95% holes will transfer or transmit through this N type of base, and therefore here there will be generation of a current, and that is called as collector current. So let's see, and hence we have seen that this IE here, IE is nothing but IB base current plus collector current, because 5% of the electrons from this are giving rise to IB, and remaining 95% are giving rise to IC. Therefore, IE is nothing but IB plus IC in case of NPN transistor, and same is the situation in case of PNP transistor, but here the current which is generated is due to the migration of holes. Therefore, IE is equal to IB plus IC. Here, current is generated due to migration of electrons, and here current is generated due to migration of holes. This is only the difference between P-type and N-type semiconductor. So let's revise the today's point, that is bipolar junction transistor. Transistors are the circuit components which are made up of semiconductors. They are consisting of two PN junction diodes as shown in figure. There are based on which type of material is sandwiched in the another type of semiconducting material. There are two types of bipolar transistors, and these are NPN transistor and PNP transistor. In case of NPN transistor, a P type of material is sandwiched in between two N type materials, and in case of PNP transistors, a N-type material, semiconducting material, is sandwiched between P-type of semiconducting materials. I have already told you how to form a N-type material and how to form a P-type material. N-type, in order to form a N-type material, a doping is done such that a pentavalent impurity is added in pure semiconducting material, and hence the electrons will be the excess, and therefore the majority charge carriers in case of N type of material are the electrons, and in case of P type materials we are doping the pure material, semiconducting material, with trivalent impurity, and therefore the majority charge carriers are the holes. Now here a bipolar transistor with NPN transistor is shown. This is N region, base region, and this is collector region. This portion is emitter, base, and collector. These are the three terminals of a given transistor. Base What is the base? The base is located at the center portion. Its thickness is very light and it consists of minority charge carriers as holes in case of NPN transistor. In case of PNP transistor also, the size of base is less as compared to emitter and collector, and its majority charge carriers are the electrons present in base. Then this portion is also made up of N type of material. This portion is also made up of N type material, but in case of NPN transistor or PNP transistor, the portion which is having less size as compared to this N region is called as emitter, and it is heavily doped. This portion is heavily doped. Heavily doped as compared to this region, means its length is more, L1 and L2. So length of collector portion is greater than the emitter portion, and the doping in case of collector portion is less as compared to the emitter portion. The same is the situation. Here length of collector portion is more as compared to the length of emitter portion, and the doping of emitter portion is more than the doping of the collector portion. Then one by one we will see the what is the use of emitter, base and collector in case of bipolar transistor. So when we apply a forward bias, why biasing is necessary? Because we are going to use the transistor in order to generate the output which is greater than input, and for that biasing is necessary, and there are various methods to bias the transistor, and one of them is to forward bias the EB, that is emitter base junction, and reverse bias to collector base junction. And if we forward bias the emitter base junction, then the electrons in emitter will start to migrate and they will cross this base push, this junction, and come to the base section of the transistor. In base section there are the minority charge carriers, that is holes. These electrons will recombine with the holes and their percentage of recombination is 5%, and the remaining 95% will get transmitted and they will form collector current. So due to the migration of majority charge carriers, there will be generation of IE, and due to the valence electrons which are created due to electron hole recombination, there will be the generation of base current. And here this portion of the transistor will give us the collector current, and this portion is also made somewhat larger as compared to the emitter in order to dissipate the heat which is produced during the working of the transistor. Here also the same is the situation. The size of the collector portion is somewhat large as compared to the emitter section in order to dissipate the excess of heat which is produced during the process. And here also when we forward bias this emitter base junction, then holes are start to move and they will reach to base. Their electron hole recombination will take place. 5% of the electron hole recombination process will give rise to valence electrons. They will generate the IB, that is base current, and remaining 95% of holes will give rise to collector current. This is the construction of bipolar transistor. Thank you.